this video, we will go over students' t-test. So t-value is equal to this equation right here, which we will go over when we solve an example problem. The top represents signal, the bottom represents noise. So one problem that we will solve will be a two-tailed test and independent, unpaired, and I will explain what this means. Sample 1, we have 20 data points, mean is 12, standard deviation is 0.25. Sample 2, 20 data points, mean is 11.5, and standard deviation is 0.2. So first, what is independent unpaired t-test? It means both samples consist of distinct test subjects. As an example, it would be to have 20 people take several brain tests without food. Then get another group of 20 people and give them food to take a similar brain puzzle. Now a paired t-test means both samples consist of the same test subjects. Example would be to have 20 people take several brain puzzles, then give those 20 people food, and then have them take a similar brain puzzle. Further, a two-tailed test looks like something like this, where 95% is here, 2.5% is on the right, and 2.5% is on the left. As opposed to a one-tailed test, where you have 95% here, and here is 5%. So when should we use a two-tailed versus a one-tailed test? We use one-tailed if we're sure of the directionality. This should be very confident. If we're not, we should use a two-tailed test. Further, when should we use a student's t-test? So these are the conditions that it works best. When N1 and N2 should be roughly the same. Also, we should have around 20 to 30 data points, and we have a normal distribution. And now we'll go back to the problem we saw on slide 1. So we have problem, two-tailed test, and independent, unpaired. They're just stating it for us. We're not proving it or anything. They're just telling us this is what we have, two-tailed and independent. Sample 1, we have 20 data points, mean is 12, standard deviation is 0.25. Sample 2, 20 data points, mean is 11.5, standard deviation is 0.2. So this right here is our t-value. So this value right here is going to be 12. Our mean for sample 1 is 12, minus the mean of sample 2 is 11.5, absolute value, divided by the square root. Standard deviation 1 is 0.25 squared, divided by n1, which is 20, plus standard deviation 2 squared, 0.2 squared, divided by n2, which is 20. If you use a calculator, this right here is 6.9843. Because the value is greater than 1, we know that there's more signal than noise. Because the value is greater than 1, that means the top part, the numerator, is greater than the denominator. If it was less than 1, then we know the denominator is bigger than the numerator. So now we will perform the student's t-test, first testing null hypothesis. So null hypothesis, there is no significant difference between the sample test less than critical value. If greater than the critical value, then we reject the null hypothesis. We could say there is a significant difference between the sample set. Next, we need to calculate the degree of freedom. It's going to be n1 plus n2 minus 2. So n1 is 20, n2 is 20, 20 plus 20 is 40, 40 minus 2 is 38. So our DOF is 38. Generally speaking, most statistics classes, you would go to the 0.05 of the table. It's kind of like 95% sure. Unless the problem wants more accuracy, like a 99%, then you would go somewhere here. But this problem didn't specify, and generally with statistics, you would want to go to the 0.05. So we check 38 and 0.05. What number does that match to? It matches to 2.024. Now, is the t-value we calculated earlier higher or lower than the critical value? So the t-value that we calculated earlier was 6.9843, which is higher than the critical value of 2.024. And earlier we stated the null hypothesis. There's no significant difference between the sample set less than the critical value. If greater than the critical value, then we reject the null hypothesis. We could say there is a significant difference between the sample set. Because of this statement right here, we know to reject the null hypothesis. So there is a significant difference between the sample set. And that's pretty much it regarding students' t-test.